Okay, in lesson 8.4, we're going to be learning about the average value of a function. Let's start with a quick warm-up. What is the average rate of change of f of x equals x cubed on the interval from -1 to 2? And hopefully we know that the average rate of change is just the slope from beginning to end. So like, okay, so when x is -1, y is -1. So when we plug in -1, we get -1. When x is 2, y is 8, 2, 8. And the average rate of change is 8 minus -1. So that's the rise is 9, divided by x2 minus x1. So 2 minus -1. So we get 9 over 3, which is 3. So this is saying, on average, x cubed is going up by 3 between -1 and 2. Now, that's not actually how it looks. It actually looks like, it's actually like increasing like this and then like this. But the average rate of change is 3. What is the formula for the average velocity? And so velocity, the way we see what the average velocity is by taking the position. So I guess we should say, what is the average velocity on an interval from A to B? And then we would say, I'll go ahead and probably fix this on the notes before I give it to you. What is the formula for the average velocity on A to B? It'll be the position at B. It's the ending position minus the beginning position divided by B minus A. So it's how far did you go divided by how long were you going for. So this is the change in position divided by the change in time. How far did you go divided by how long did you spend going it? That's how fast you were going on average. Okay, so great. So if the velocity is given by this, we can say what the average velocity is by doing what? And the answer is not by doing y2 minus y1 over x2 minus x1. The average velocity is going to be the position at B minus the position at A over B minus A. Well, is this the position? No. How could we get the position? Well, we can find how much the position at B minus the position of A changed. So I guess what are we looking for? 1 to 3? The position at 3 minus the position at 1 divided by 3 minus 1. This is the average velocity. Okay? And we can't get that directly from this formula, but what we can do is we can say that we know that v of t is the derivative of position. And so position is an antiderivative of velocity. And so we know how to do this. This is how much the position changed by is the integral from 1 to 3 of v of t. So it's adding up all those velocities will tell you how much the position changed by, which is what we wanted up here for the average velocity. It's the change in position divided by the change in time. Here's change in position, change of time over change in time. And so change in position divided by change in time. And now we need to do the fundamental theorem of calculus here. So we're going to do the antiderivative. So t cubed divide by 3. So we raise the power by 1, divide by 3. We raise the power by 1 and divide by 2. And this is going to be evaluated from 1 to 3. And all of this is over 2 because 3 minus 1 is 2. So let's see, what is this? T cubed, 3 cubed is 27, plus t squared is 9. 3 times 9 is 27, minus 1 cubed is 1. 1 squared is 1. 3 times 1 is 3. And all of this is divided by 2. So we get 54 minus 4 is 50 over 2, which is 25. So the average velocity was 25. And guys, if you look at this graph, what this is saying is, so here's 3, I'm going to put x squared instead of t's because it's easier. So 3x squared plus this. If we graph it, let's graph from, -1 to 5, that's fine. Since the average velocity is going to be like 25, let's go up to 50. Let's actually go up to 60. Let's see. So here's a graph of the velocity, and what we're saying is between time equals 1 and 3, so between here and here, the average velocity we said was 25. And if you look, like that's like kind of on average where it was. So how about the average acceleration? Try this one on your own. What is the average, if the velocity is this, what's the average acceleration of the particle? Well, the acceleration is the rate of change of the velocity. So it's saying, what's the average rate of change of this? This is y2 minus y1 over x2 minus x1. So we're going to plug in 3, get 27 plus 18. So that's y2 minus y1. We're going to plug in 1 and get 3 plus 6. We plug in 1, divided by 3 minus 1. And so we get 45 minus 9 is 36 over 2, which is 18. So what this is saying is, on average, between t equals 1 and t equals 3, the velocity was going up by about 18. I can write that in as this. This would be like, what I say, 18 times x minus 1 plus 9. Oops, I put x minus 4 here. So that should be the 10. Yeah, so that's the secant line. And you can see that on average, that's how much it was going up by, was 18. That's the slope of the secant line. Okay, in general, so we've got average value, the average value of velocity versus the average rate of change of velocity. So the average value of a function, the way we're going to find it is just like we did up here. We're going to see how much we're going to treat it like a slope. So we're going to treat it like this value is a slope. And what we're going to do is we're going to do the integral of f of x. And that'll find the antiderivative, which would be like some big f of x from a to b, the average from a to b. So we'll get f of b minus f of a over b minus a, and this will be the average rate of change of the antiderivative, which will be the average value of f. So this is the average value of f, and we have to do it over b minus a. So this is a formula. So the average value is you do the integral and divide it by how much it changed by. And, you know, going back and forth between derivatives and function values is a little tricky, but I hope we realize that, like, pretend this was a derivative for a second. Let's say we wanted to find the average value of a derivative. Well, this is the integral of a derivative is f of b minus f of a over b minus a, and this is the estimate for this is the average rate of change over b to a. Right? This is the average rate of change, which is what this is finding. This is the average rate of change. So the average value of a function, you do the integral, divide by b minus a. Sometimes we'll write this as 1 over b minus a times the integral from a to b of f of x. This is, you know, dividing by b over a is the same as multiplying by the reciprocal. Sometimes you'll see it like this. Compare that to the average rate of change of a function. The average rate of change is just f of b minus f of a over b minus a. Now, this is an f of b minus f of a. It's just for the antiderivative, right? Like, that's what this is equal to. So, okay. So keeping these straight can be a little tricky. What is the average value of the function? Let's see how this works for sine of x. The average value of sine of x is going to be the average value, not the average rate of change. The average value of it is going to be the integral from 0 to pi of sine of x divided by pi minus 0. So this is, I'm going to put it in front, 1 over pi times, what is the integral? How do we do this integral? We're going to do the fundamental theorem of calculus. We're going to do the antiderivative. And I know it has something to do with like cosine of x. The derivative of cosine of x would be negative sine of x, so this needs a negative. And this is going to be evaluated from 0 to pi. Okay? And we don't need the plus c here because they, of course, cancel out when you do the definite integral. It'll be like plus c and then minus c when we do the pi and the 0 here. So let's see. Cosine of pi is over here. Cosine of pi is negative 1. So we're going to get 1 over pi times negative 1 minus negative cosine of 0 is 1. So minus negative 1 again. Okay, so this is 1 over pi times this is 1 plus 1. So 2 over pi. So the area of sine of x, but the average value of sine of x, and let's graph this real quick. This is saying like the average y value. When we say the average value, we're talking about like the average y value. The average y value between 0 and pi, let's see, let's go from negative 1 to 1, of sine of x, saying, okay, how high is this on average? And we're saying that the average value that it is pi over 2 over pi. 2 over pi. And what you'll see here is that the integral of that, like it may look like this is a little too high, but it's not. If you do the integral of 2 over pi and the integral of sine of x, both will have the exact same area. The amount of area that's too low, like you'll see like this part f of x is too low, this part f of x is too low, that area is exactly canceled out by the amount of area that is too high. This is the average value of f of x. Try this one on your own. What is the average value of 6x squared on the interval from 1 to 3? So the average value of this function is going to be the integral from 1 to 3 of this function divided by 3 minus 1. So I'm going to put this in front. 1/2 of, what is this integral? Well, we need to raise the power by 1, divide by the power, and evaluate it from 1 to 3. Okay. I'm going to plug in 3. This is 1/2 of 3 cubed is 27. 27 times 2 is 54. Minus, when we plug in 1, we just get 2. So 54 minus 2 is 52. 52 divided by 2 is 26. So 26 is the average value of this function. Again, on average, this y value is like it starts at, the y value starts at 6. The y value ends at 54, and the average y value ends up being 26, right? So when x is 1, the y value is 6. When x is 3, the y value is 54. And, you know, obviously the average value is going to be somewhere in between there. Okay, I love this problem. You do need a calculator on this. You've got a figure with a line segment from 0, 4, so this is 0, 4, until 8, 4. So it's a line segment. So this is just a straight line. And then it becomes a quarter of a circle with a radius of 4. So 1, 2, 3, 4. 1, 2, 3, 4. This is a quarter of a circle. What is the mean value? This is another word for average value. What is the average value? Now look, guys, the average value, I can already tell it's probably going to be this one, if I had to guess, because look, what's the average height that this thing has? It has 4, 4, 4, 4, 4, 4, 4, 4, 4, 3 point something, 3 point something, 2 point something, you know, 1 point something, and it's going down, right? So, so it's going to be just a little bit lower than 4. I know the value was 4 for a while, and they got lower than 4. So what was that average value? You know, it's probably like around here. This is probably the average value, so that the area above and the area below are the same. But let's actually find this. The average value of this function is the integral from 0 to 12 of f of x divided by 12 minus 0, right? So how do we find this integral? Well, we don't have an equation for this here, but you can use your geometrical rules to find it. So this isn't going away. The geometry stuff isn't going away. We need the area of this, and this is just a rectangle. This is the length of the rectangle, which is 8, times the height of the rectangle, which is 4. So this area is 32. And then we need the area of this quarter of a circle. So we're going to add in pi times r squared divided by 4, because it's only a quarter of a circle. We need to divide it into 4 parts. Divided by 12. So let's see. So we get 32 plus 4 squared is 16. 16 divided by 4 is 4. So 4 pi divided by 12. It's 3.714. Okay. I knew it wasn't going to come out to be this one because I knew this part was going to have a pi in it. And I was like, it's not going to come out to be an even number. That's why I knew it wasn't this one clear. But it was going to be one of these. And then because I knew it was going to have a pi in it, I was like, it's got to be this one. Okay, guys, this is a hard one. What is the average value of y for the part of the curve y equals 3x minus x squared, which is in the first quadrant? Try this one on your own. Whenever they start talking about like where it is, you really want to draw a graph. So, you know, this is some sort of quadratic, and I'm going to factor it. So it's x times 3 minus x. It has zeros, x-intercepts at 0 and at 3, and it's concave down because of the negative x squared. So it looks like this. You know, this goes down here. So we're talking about this. You know, what's the average value of this guy? And that's in the first quadrant. So not here, not here. This is the first quadrant. So the average value is going from 0 to 3, and we needed to do that by, we needed to know it was going by 0 to 3 by graphing it and finding where the first quadrant began and ended. So it's going to be the integral from 0 to 3 of 3x minus x squared dx. Let's just do this. We're going to raise the power by 1 and divide by the power, so 3/2. We're going to raise the power by 1 and divide by the power from 0 to 3. Now this is the integral. That's the area, and then we need to divide by 3 minus 0 to get the actual average value. So, okay, so let's plug this in. 3 squared is 9. That'll multiply times the numerator, and we'll get 27/2 minus 9. So that's when x is plugged in as 3, minus, when we plug in 0, we'll get 0 for both of these. Okay, divided by 3. This is all from this. Let's see, 27/2 minus 9, 27/2. 9 is 18/2. That's 9. I had to get a common denominator. So 9/2 divided by 3, and dividing by a whole number is the same as multiplying by the reciprocal. So 9/2 times 1/3 is 9/6. Man, there's a lot of ugly fraction math. And now we need to simplify this by dividing by 3 over 3. So this is 3/2. Last one. Oh man, we're going to get in under 20 minutes today. You guys are going to need to do some practice on this to get better at it. Estimate the average value. Man, there's this fly that's been like flying around in here every day. It's so annoying. Estimate the average value of the function. So here's this function by using a left Riemann sum. Now, the values of this function are like 10, 30, 40, 20. The average value looks like it's going to be around 20 to me, right? Somewhere between 10 and 40. I don't know. Maybe it's about 25. I don't know. But it says to estimate it. So what's actually happening here is at 2, the value is at 10, right? At 5, the value is at 30. At 7, the value is at 40. And at 8, the value is at 20. So we don't know exactly what this function looks like, but we know the average value is going to be the integral from, we're going from 2 to 8, so the integral from 2 to 8 of f of x divided by 8 minus 2. So we can't find this integral, but we can estimate it using a left Riemann sum. So the left Riemann sum is going to go over and come down, over and down, over and down, and we won't end up using this last point. So this estimate will be 10 times this width is 3, from 2 to 5 is 3, 2 plus 3 is 5, plus this height is 30 times a width of 2, 5 to 7 is 2, plus a height of 40 times a width of from 7 to 8 is just 1, divided by 6. So 30 plus 60 plus 40 divided by 6, this is 130. So this is 100 plus 30 is 130 divided by 6. And we can divide these both by 2. So 65 thirds. Or this is 21.6 repeating, I believe. Now, notice that makes sense, right? Doesn't the average value, it should be somewhere, it has to be in between 10 and 40. It has to be between the lowest and the highest value. Just like if you had found the highest value here, what is the highest value there? It's going to be 1.5 is where the vertex is going to be, so 3 times 1.5 minus 1.5 squared. This average value had to be between 0 and 2.25, and it is. It's at 1.5. So like the average value is at 1.5 here. This average value had to be between 0 and 4, and it was 3.7. So the average value is always in between the highest and the lowest value. And so that's a nice check to see, like, did you do something wrong? The most common mistake is, like, kids will write this and then they'll just, like, forget to do the dividing by 6 later. They'll write it correctly and then they'll forget the dividing by 6 and they'll just end up putting that the answer is like 130. It's pretty common. So guys, that is it for today on average value. Hopefully you're feeling pretty good about this stuff. If you haven't passed your mastery quiz, your integrals mastery quiz, that is something you need to get done. I hope you have a good rest of your day, and I will see you next class.